The question actually it was asking us about what is the role of the computer investigation whenever we talk about the cybersecurity field. The computer investigations mainly they are a context of malware analysis, crime scene processing, and things like that. We're not going to investigate for troubleshooting the hardware and that's it. No, but we have a purpose, and mainly since we are talking about the cybersecurity, there will be a crime scene or something, actually an attack or a hack or let's say a breach, data breach or vulnerability. It's an exploitation at the end of the day. So the computer investigation, in our view as cybersecurity specialists, is the context of exploitation. Exploitation of what? Weaknesses, vulnerabilities, let's say events happening, logs, and so on. Exploitation, we cannot exploit for the logs, but we can use the logs to accomplish the exploitation process. No more, no less, simply. So chapter number 7, immediately let's pass to the next unit, which is the denial of serves, via which actually we are going to see in detail the scenario of the distributed attacks. As first definition, as in the beginning, we start with defining what is the DOS, denial of service attack. It's a view via which we see a service forbidden from being actually delivered, users actually being denied from receiving services and things like that. We do not see any destroyal, any deletion, any discrimination. Yes, discrimination somehow, yes, because we are going to deny the access, or the attack is denying access in that way. So it's a behavior via which we prevent access to services, mainly access to resources, not only services, because even if we deny the access to an entity inside a database, it can be considered, it can be seen under a DOS attack. Yes, so not only to deliver a web page or web service, but also sources and resources can be question of DOS attacks. Just being forbidden from being delivered to the end users. Whenever a legitimate request is passed, there might be actually just a waiting list happening, and the user will not be succeeding to access or to reach the resource. This is due to what? Due to either compromise in the bandwidth or the processing memory, where the processor is processing the requests, or the complete capability of the processor is being utilized for the let's say processing the requests, or all. Processor, memory, and bandwidth. Yes, so the attacker, in order to succeed in doing a DOS attack on a device, he has either to compromise the capability of the CPU, the central processing unit, completely, or completely compromise the memory where the processor is working completely, or fully occupy the bandwidth from where requests and responses pass through in outflow, or all of them. The attacker has to occupy all of them, has to compromise all of them. And by doing so, there will be denial of service. Any legitimate request comes to the computer, to the device in question, there will be no refusal, but just waiting. There will be a waiting list where the users or the legitimate request will be put in. As we said, those are the things to be attacked, and here's what the attacks do. They would attack the bandwidth, the resources, or the framework or the environment, or the designated applications resources. All of them they will actually be attacked by, because to forbidden their delivery or their service delivery, their capabilities. whatever. This is actually something related to the United States laws. Example of a very famous DOS attack is the ping of death. We saw that in the lab. Yes, I know. During the chapter number 6, which is talking about the malicious software. Yet still here, the ping of death is a scenario which we may cause a device to be incapable of replying legitimate requests by just pinging him with big bytes and with a huge number of requests. Actually, those requests, they are simple probes. The ping is a simple probe. Hey, are you there? It is like that. Just if we are asking a computer, hey, computer, are you alive? Are you alive? The computer has to say, yes, I'm here. I'm here. Hey, computer, are you here? Yes, I'm here. Hey, computer, are you alive? Yes, I'm alive. Think like that. It's a simple probe in the ping. Or ping in a device means probe in a device, means checking whether he is alive or not. To check means you are sending the computer to the device just a request, hey, are you alive? He will say, yes, I'm alive. This needs space and time, space in memory and time to execute. Okay, the ping is simple, just one, let's say it's 128 byte size. But if we send, for example, 1 gig of bytes for every request, and not only that, we send trillions of requests of pings, what would be the case? The case, actually, the computer will fail replying all of them. He will just keep waiting all the pings to come because his ping is very heavy. It's not 128 bytes only. It's very heavy. For example, 100 megabytes or 1 gigabyte or something like that. If we succeed, actually, there is no capability to happen at that level. But even though the ping is sending a heavy byte size, and the attacker is not sending one ping, it is sending trillion actually is set, huge number of pings at the same time to the same destination, the attacker. So the attacker will be overwhelmed. He will not be able to handle all the requests. He will be trying to fix and to not to fix, but to reply all of them one by one. And all the other legitimate requests that come after those pings, they would be put into a queue, waiting. Thus, the DOS attack has been succeeded. Here we talk about the frozen ping or the ping of death. Usually, actually, the ping is not related to the internet only because we can ping devices in a local network. We may talk about device to be receiving a ping of death, but from the same network. Yes, we can. Yes, simply since it's a network, since the computer has network, the ping would be actually successful. There is no header for the ping. The ping actually it is serves to be delivered to check up the status of a device in the network. Yeah, absolutely. The ping actually is, serves under the ICMP protocol, ICMP protocol, Internet Control Message Protocol. And as we were discussing, the size of the request to be submitted is a question. Originally, actually, there is 128 bytes to be sent for the destination or to the destination within every single ping, but the size to be customized. Once we talk about the size of the ping to be, for example, 100 megabytes, just to specify that the byte has to be occupying that space in memory, even it's empty. It is much more considerable. Mainly this internet control protocol, actually this ICMP control message protocol, it's not only for pinging, it's not only to be utilized for controlling the behavior of the ping, no. But actually it is as per the literally said here, literally speaking, when we talk about the internet services. And specifically you talk about communications in between devices, the ICMP would be seen in action. So for the remote communications, the ICMP protocol might be seen in action. The spoofing is one of the scenarios via which we may succeed in doing, because if we just send a ping of death from a device A to device B and the device A is recognized, so very easily it will be caught and very easily it will be actually stopped and blocked. But if we do spoof the sender's identity, so that will be much more complex for the destination to catch the attack or to stop or to block or to deny the attack, because the source is already a new and unknown source. By doing what? Spoofing the address, to spoof the address, and we know what does mean spoof. Other activities that actually the ICMP do guarantee over the network actually is the generation of the tricking environment, which is nominated here the honeypot. The honeypot is one of the we define that actually in computer security course. It is a sort of a network zone via which we see services mimicking the real services delivered by the real network, and they are only to be used to trick and track and, let's say, trap attackers. Trick them to say that this is the service you need, for example, and track them to see what they are doing, what are the services they search. Trap them. Once they get in that network zone, they would be caught immediately. They would be recognized. Honeypot, honeypot to catch. So the ICMP can be utilized to generate such, let's say, to control or to make the honeypot run. We define the Fluden ping, or the ping of death, in an abstract way. We said that it is a sort of a probe sent from the source to destination to check the status or the running status, whether it is alive or not. Are you alive? Yes. The destination says, yes, I'm here. Actually, simply said that. But technically, there might be 3 packets sent in both directions: a request, an acknowledgement of reception, and acknowledgement of yes, coming. 3 packets would be seen in action. The request is the synchronization. Actually, the sender will synchronize his path with the destination. Yes, this is my path. I'm going to send you through this path. Synchronization. Synchronization. The receiver, once he receives the synchronization request, he will say, yes, okay, I'm here. Synchronization acknowledgement. Synchronization acknowledgement. It's not new to us. We know that. Then after an acknowledgement saying that, okay, I'm sending you data now. Number 3. This is how a probing happens. Probing means a pinging happens. Synchronization, Synchronization acknowledgement, acknowledgement. This is one probe, one ping. There are 3 packets to be communicated in between the sender and the receiver. Then after comes the communication of the media. Then after, the files would be shared or whatever would be happening here later on. I come back. Since spoofing, synchronization in spoofing is to spoof the destination. You spoof the destination saying that I am the legitimate sender, so accept me. So to spoof the identity of the sender, to trick the receiver or the destination, to mimic or to convince him that he is the original or the standard and the, let's say, trustworthy destination. The SYN spoofing, it has a target. It is not only to spoof the source and that's it. No, but it has a target. Is to gain access for future purposes, actually. The routers or the network devices responsible for drawing the paths in between devices would be actually spoofed by adding falsified and spoofed IDs in order to be utilized in future times. Overflowing the tables used to manage, that means here the connectivity in between the sender and the receivers, the senders and the receivers. Once happened, the legitimate sources would be denied from accessing. Yes, so we saw that. This is the legitimate. This is the legitimate scenario. This is the legitimate scenario of any probe and task. It happens like that. But when you talk about the spoofing here, the request or the synchronization request would be communicated with the destination with a falsified ID. What does it mean? Means the server, if he replies, he will reply to the falsified ID, which is the spoofed client, which is the victim, or sorry, the attacker. So the replies would be sent directly from the destination to the attacker, not to the legitimate computer. Why? Because the synchronization ID was spoofed. Actually, we have to recognize clearly how the synchronization can be spoofed in the sense of how the ID or the ID of the source would be spoofed from the original stage. Yeah, absolutely, because actually the attacker has scenarios in plural how he can spoof the source. The very famous and the very common way is to randomly specify addresses and from which the source might fall, from which the address of the source device might fall. So thus, the destination will accept such a request, and the replies of the destination would come to this falsified address, which is the attacker's address. Another scenario via which actually an attacker can compromise and spoof the synchronization ID is by overloading a service delivery over a server to block him from sending the reset or setting the reset request. Other time he might actually have a copy of all the replies of this server or this service provider, because there will be no reset and everything is exposed. Another scenario is by just sniffing and altering submitted packets. Sniffing and altering submitted packets. Sniffing and then after modifying. Then it is spoofing. So here the reset is one of the key solutions to secure communications between source and destination usually. Reset. Once actually a destination feels, or let's say smells that there is an attack happening, he would be actually set or submitting a reset request in order to initiate the communication from the beginning. There are dedicated, let's say, protocols and scenarios via which we can flute. Whenever we talked about the spoofing, there will be actually a target, and most of them is to flood the network, not only a target. There might be scenarios via which to succeed in spoofing, which is to flood a communication or to flood a target, like in here in the second option here, in order to deny him from sending a reset. And this flooding, it is a scenario via which we see the network overwhelmed, means it is not able to visualize and process legitimate requests. And to do this flooding, the ICMP has to be put in action in the sense of we're going to generate a packet with a dedicated byte size. And this packet is going to be resent again and again and again. So this is the context of, yes, flooding the destination. Whatever the example is. Just one of the very important things actually is that the comparison between the SYN spoof and the SYN flood, the SYN spoof and SYN flood, synchronization in all cases, but whether we are going to spoof or to flood. The synchronization is spoof, and it's in the sense of spoofing the ID of the sender. Who is the sender? It is spoofed. Only means the ID or the IP address of the sender is being modified. So we talk about synchronization spoof. Yet when you talk about synchronization flood, there is something that has been flooded in the sense of it is capable of delivering, let's say, 10 requests per second. It is being occupied and requests to submit 100 requests per second or 100 responses per second. So it's being flooded. It means more than its capability requests are coming. Flooded. Here, just a reminder, the synchronization. SYN, it's a context of probing destinations. Hey, are you there? Remember this. Remember this. Are you there? Just that's it. Probing availability. Probe to probe. ICMP is not the unique protocol available on the network, and it is to be run on the network layer. The layer number 3 in the OSI model. It is for the connection-based networks. Yet for the wireless and the connection-less based networks, there are other protocols to be utilized. And the main protocol running on the protocol package running on top of the wireless networks is the UDP protocol, user datagram protocol. So thus here the packets to be used for probing and the packets to be used for achieving the DOS attack is the UDP packet. Still the same scenario is to be applied, yet subdivision of the packet in addition to the byte size, data size is different. We are talking about a wireless communication. Any questions here?
No, Mr.
Okay, we'll continue. From this point only, since we understand a little bit actually what does it mean DOS and what does it mean denial of serves, we define the DDoS, distributed denial of serves. Here we talk about the DOS simply, but destinations are the same, yet the sources, the doer, is a list of actors. It's not only one attacker. We have a list of attackers geographically segregated, attacking the same victim at the same time. Distributed denial of serves. We define that actually. Technically, I'm going to speak a little bit actually to remind you and to refresh your minds. There will be actually compromised devices using bots and using backdoors to generate a botnet made of zombies or made up of compromised devices. And this botnet or those list of zombies or those compromised devices, they would attack a dedicated device based on his ID, which is an IP address mainly, at the same time. So we talk about distributed denial of serves. Or what we defined earlier is still applicable, yet with the consideration of the attacker that it is a list of attackers, not only one.